Hello everyone, let's talk about this question. It's called Fix You. We're said that we have been given a conveyor belt sort of grid with n rows and m columns. The cell they say is the ith row from the top and jth column from the left, labeled I and j. We're said that each cell except n comma n, which will be our target cell, will have a direction, either right for R or D for down, assigned to it. And that is how the conveyor belt will move. When it encounters a right, it will increase the J value or the column value. So from column 1, it will go to column 2. If it sees a down keyword or D, it will move downwards. So it will go from row 1 to row 2 and so on. We are said that the conveyor belt is functional only if wherever we place bag, it ultimately ends in the cell n comma m. We're said that we're allowed to change as many directions, right, like these rights and lefts or rights and downs, as we want. But our goal is to make sure that wherever we place our luggage, it ultimately ends in n comma m cell number. Our goal is to find the minimum number of changes that we would have to make to achieve this. In our inputs, we have t, which is the number of test cases. For each test case, we have two integers n comma m, which will tell us how many rows and columns there are on the conveyor belt, and they will also treat as our final position where the bags should end. It says for each n and m, a of n comma m is c, which is the end of the conveyor belt. For example, in this example, when we start from this position, we move towards the right, which will lead us to another right. We'll move another right, which will lead us to a down. So we move down, and then we see this r, which means now we have to move to the right. We know that this isn't possible because anything that goes outside this table or conveyor belt is automatically not considered as a possible solution, and then we have to make some changes. Let's say now we start from the first D in the second row. We see D here, so we move down. We see a R here, so we move right. We see an R again, so we move right again, and then we get to C, which is our goal. Now if we look at a couple of other examples, this might be a little too big, but let's still look at this. In this situation, we can look at all of this and consider all of the possibilities, but since we know that we can only move R for right and D for down, we would ultimately end up in the very last column or the very last row. So let me try to write this. Since we can only move right and down, no matter where we start, we will ultimately end on the last row or the last column. This understanding is the crux behind this question and the way to solve this, because when we understand that we will ultimately end up on the very last column or the very last row, like here, all we have to do is make changes on these last rows and last columns. For example, in this case, we are in the last row. We see a down here. A down here would make the conveyor belt not valid, so we need to change the down to a R. So that increases our count or changes that we're making. We see another D, so moving down, that would make the conveyor belt invalid again, so that will be changed to a R. so on and so forth. For all the values in the very last row, if we see a D keyword or D character, we will increase the count of changes that we have to make by 1. Similarly, on the very last column, whenever we see an R, we know that that would make our conveyor belt invalid. Whenever we see the R character, we will increase the count of the changes that we would have to make by 1 again. That is all we have to do in this question. We have to input all of this stuff, look at all of the D's in the very last row. If there is a D, we'll increase the count. Similarly, we'll look at all of the values in the very last column as well. If we see an R there, we would have to change or increase the value of our count variable by 1, and ultimately we'll just output the count variable. So now let's look at the code. I will start off with my template here. We will input test case. While test case is positive, we will input our two variables that we have been given, n and m. Once we've done that, we will initialize our vector, which will be a string. This will, let's say we can call this grid, and this will have n values. Once that is done, we have to populate the grid. So for I0, I less than n, we will input grid at the position I. After this point, once we've populated the grid, we will initialize our count to 0, and after this we'll start counting the number of D's and R's in the last columns and the last rows. So like we said, in the last row we do not want any D's because that would make the conveyor belt invalid. So for int j equals 0 and j is less than m is the column. So when we're looking at each of the values in the bottom row, we would have to go through each of the columns to do that. We'll check if grid at n minus 1, which would be the last row, and j, which will be the number of the column, is equal to d. If that is d, we will increase our count variable by 1. For our column setup, we do not want any r's. So for columns, we'll do the same thing, but in this case, we'll run through our n, which is our row number, and then we'll check if grid at position I, so the ith row, and the m-1 column number, so the last column, if it has any r's, we know that will make our conveyor belt invalid, so we'll increase the count, and once that is done, we will see out our count. One thing we have to include here is vector because we used it, but that is about it. This is the idea behind this question, and this is how I solved it. If you have a better way to solve this, please let me know in the comments. I would love to know. That is it for this question. I'll see you in the next one.